This is a talk about vehicle electronics in modern classics. It's about the fact that pretty much every car that was produced from 2000 or thereabouts onwards will have some electronic components in it. So all cars are designed around 100,000 mile life for components and other things, and that includes the electronics. And people have this view that solid state electronics like this never go wrong. That's not true. And for some reason the manufacturers keep the information about those things really, really tight. And so reversing engineering stuff is really quite difficult. So what are we talking about? We're talking about engine control modules, gearbox control modules, a thing called a body control module, which is putting stability or the security system and so on. There are door modules that stop the door from cutting your finger off if you wind the glass up, right? There are fuel pump modules which cut the fuel pump if the car is in an impact and things like that. So in that car there are 9 different modules, and they all communicate with each other, and nowadays everyone talks about CAN bus, but that's not where it started. So in this car, it uses a mixture of Ford protocols. It uses Kiwi Climb, Ford PWM, and a proprietary Ford CAN bus. And it's really complicated for no good reason. Okay, so what do these things do? Well, if it's an engine ECU, it runs on the 6 chips that are there, the 6 coil drivers which fire the sparks. It also runs the fueling system, and depending on how complicated the car is, it will have some intelligence in it. So in this particular case, there are 3 power PC chips in it. Same thing that you would find in your Apple computer. And these are looking at things like the exhaust gas mixture, and they're using that to modify the performance of the engine. This is a relatively simple ECU compared to what cars are running nowadays. So this is a 2002 or 2000 ECU. It doesn't do cruise control, it doesn't do traction control, it doesn't do launch control, but you can get all of those on. So what goes wrong with them? Well, these silver things here are electrolytic capacitors, and they are known to fail. Interestingly, we have not had this problem with these ECUs, but in a lot of Jaguar and other ones, it's these silver devices that fail. These early ones are very susceptible to a voltage spike. So the sort of thing that you can do to your car which will absolutely kill it is jump start it, and I'll explain at the end why you've got to be careful about starting your cars. So on a generation before this, on the DB7s, they tend to blow the coil drivers. So if a coil driver starts to fail, it'll blow a chip on board. So that means your car only runs on, well, if it's a 6-cylinder car, 5, or if it's a V12, it'll be running on 9 typically. So the question is, can we change those things? So we've learned as a group of users how to identify which chips have failed. You then go and harvest old chips, because they're all obsolete, off a Ford or somebody else's ECU and plant it working on the new boards. When we had this problem in the Vanquish, and it's a problem where only half the engine starts when the ECU is cold, we went and looked at every single Ford ECU of the same period, and we found that actually Aston had a unique ECU for this car, which was wonderful, but caused us a problem. The ECU would fail when it was cold, which means that the physical chip was failing. And that was good because it meant that we could test for it working or not working. And that man over there, the wizard, eventually ended up with a stainless steel bolt in boiling water, going around the individual microchips to work out which one came to life when he got it hot. I bought all the chips in the world that I could find that were still left, because that's another problem. All of these chips are designed for a life, and the industry moves on very, very fast. So when I went looking for this particular chip, I was able to buy 356 chips. That was it, and we haven't seen any more. So there's a limited supply to fix them. Okay, so once you put the chip on, that's great. The problem is that you then need to put the software on, and that requires a different kind of geek. And the one with the sunglasses on his head is the geek who worked out how to get the software off the chips and back on the chips. Interestingly, we got a bit of a clue because these are very similar to what's in a Jaguar S-Type, and we find that Ford, who was scared stiff of the idea of drive-by-wire because they thought they could get an uncommanded throttle and the car would then crash. So what Ford did was, using Jaguar, they tested drive-by-wire, but in the Jaguar S-Type they actually used the wire control, which is a servo, to run idle, so it would collapse and fail closed rather than open. So the car wouldn't run away, the car would stop if there was a failure. And having tested it, they then put it into action, and that was the first drive-by-wire car out of the Ford stable. Trying to work this out is a bit like trying to play chess blindfold with your hands behind your back and weightless. But you can do it. So if you happen to be a TVR owner or a Jaguar owner or a Rolls-Royce or a Bentley owner, and you've got an ECU that's failed, you might need to panic, but don't despair, because it is possible to work these things out backwards. Not easy, but it's possible. We were lucky because we had this temperature on-off switch to help us. It did take us 2 years to do it, so you've got to be persistent as well. So electronics are they're a bit of a worry to most people, but you shouldn't give up hope. Okay, so all modern cars have an alternator, and the alternators generally are pretty smart. So the alternator is looking at the voltage in the battery, and it's going, okay, I need to give it lots of voltage or not so much voltage and amperage. If you jump start a car, you take another battery, you put it alongside, and so when the car starts, the alternator looks and it sees the jump start battery, and it goes, everything's okay, it's got a jump start battery, it's 12 volts. The moment you take the jump start battery off, it sees your dead battery, which is nothing. So it whacks out 100 plus amps. So if you have to jump start a car, and my advice would be don't if you can help it, but if you have to jump start a car, leave the jump start battery on for as long as you can so that you get some power into the battery, and before you disconnect it, turn on the lights, the wipers, the heater, the air conditioning, turn on every bloody electrical circuit you can, so that when the alternator kicks out 100 amps, you're pulling 55 or something, and you don't get as much of a voltage spike. The voltage spike is what fries these. And you can protect against it by using what we call collapsing diode circuits on it, and we make those for the cars that are susceptible. Manufacturers have got a lot better, so a modern Aston or a BMW will tend not to have this problem because they've protected the circuit so much better. But as a general rule, don't jump start. If you do, make damn sure you turn on every electrical circuit before you disconnect the jump start battery. But an Emerald ECU, if you use that as an example, or a Motec or anything else, you have to program it. Getting it to run the engine is not that difficult. The problem comes when you want it to talk to all the other modules in the car. And we had that experience. I put an automatic gearbox in this car. Running the automatic gearbox is not difficult. You need a gearbox controller. What is difficult is getting that to talk to the car ECU and the safety ECU. So in theory, you can take a BMW ZF gearbox out of the BMW, and you can in theory stick that into an Aston Martin. The problem is the computer that's running the BMW gearbox, the first thing it does when it wakes up is it goes, well, where's the engine ECU? Where's the stability ECU? Where's the other ECU? So it's software as much as hardware that's a problem.
As you see these over here, these are the coil drivers. There's two missing, so if it was a V8, it'd have the whole lot, right? Because it's running a V6. You have electrolytic capacitors, which everybody thought would be the original problem, and it turns out they're not. And the rest of that board is really about fueling, spark, timing, and so on. But you've then got the processors, right? And there are three big PowerPC processors, which is what are on an Apple computer, and those are looking at the exhaust gas mixture, and they're monitoring and altering things. So if you picked up one of these from a Jag or a Ford or anything else, the amount of stuff on the real estate would depend on how sophisticated the car was. So as the cars got more, they added more to the top board. And these are unique to Vanquish in that they've got this chip on the board. That's what controls the drive-by-wire. And they Ford experimented, in fact, with Jaguar first with electronic control, but what they actually did was they put a motor in the S-Type which could only close the throttle. So they used it for idle control, but they used it where if it failed, the car wouldn't run. So they wanted to see how well it worked in a car environment. So they used it in a fail-safe mode, and the Vanquish was one of the first cars they did where they could actually drive by wire. And they had to do that because Ian Callum insisted on a low bonnet, and they normally in a V12 or anything else you would simply put one throttle body up the top feeding everything, but they had to go with two throttle bodies, which caused them all sorts of issues, and they had to use Bosch ones for low profile.